We're going to talk about Frank Ithizas, who is a contributor of MapLibre, is going to talk about faster maps, smaller MapLibre, vector tiles, and what's next. Over to you.
So, hello ladies and gentlemen. Today we're going to talk about maps, smaller MapLibre vector tiles, and what MapLibre is about. So, what is MapLibre? We are a number of projects which you might have heard of, such as our web renderer, our native renderer, which is on iOS on native and embedded devices, our style editor, Maputnik, of our styling language, and our Rust-based tile server, Martin, which the second talk is about. I switched them around to confuse people. So, we are based on a very, very large community. If you are a part of this community and don't you see yourself on the map, please contribute to the map and put your name on the map. We love that. So, we are, in summary, we are map and everything below that, from bits to pixels, the entirety of the stack. We are based on a Mapbox clone because Mapbox in 2021 decided to not be open source anymore, which is fine, but we needed to be open source, so we forked them. We have a community elected board and solid governance, which is the basics for any open source project. We have companies and individuals contributing to us, and we accept donations and give grants. So, who are our sponsors? Our sponsors are big tech and a variety of very cool companies. Also, big tech is cool, but different. And the ecosystem makes it happen. So, bit of a timeline. We started in 2020. That is likely what you all know. But we have progressed a bit. In 2021, we launched our docs and a new renderer and a native version of our product, the open source product. In 2021, we also switched to TypeScript for the web. Then a few of our sponsors joined. In 2022, we started a board. We migrated from WebGL to Metal on iOS platforms because Apple was going to deprecate it. Still hasn't deprecated it, but we were back then very scared that it's going to be happening very soon. And in 2024, we migrated to Vulkan because that is a much more future-proof way of doing things and also much more cross-platform, plus has a variety of performance benefits. And in 2025, we also added the web. Okay. That is the past. What can you do with us? You can use us with your data, which might be Google, which might be here, which might be Esri. I've heard lots of people here use Esri, that's why I put the slide in. So, who is using MapLibre? Well, it's a variety of big tech, as I've just said. We are in every one of these Amazon delivery vans. We are DMAP, which the Amazon drivers curse about, or not curse about. Some of them like it. That's kind of fun. We are also in a number of products that you have on your phone, such as Wikipedia, Bing Maps, like a wide variety of navigation apps, like tons of them out there, and like a larger variety use us, the other variety uses Mapbox. It's fine. We are in a few ride-sharing apps like Lyft. We are in Grab, which might be more in the East Asia specific region. And we are powering Street Complete now. Anecdotal evidence, the number of crashes on Street Complete has reduced to basically near zero since they switched from 10 gram to MapLibre, which is great. We are more stable, not crashing. Basics. We are also in a few cars, which you might know, like Rivian. That's an American car company. They build like SUVs. I don't think they're in the Indian market, but Toyota likely is, and we are in few Toyota cars. But that doesn't tell you a lot. We are a renderer. Like what is MapLibre? So we are the chef, which cooks up the map. And we do that from data and which is supplied by a tile server in a tile format. So why am I putting the tile format here? Because we are building a new tile format, the MapLibre tile format. It's 3 times faster, 3 times smaller. So in total, it will be faster on your device, no matter how fast your device is. It's better in every way, I think, except implementation difficulty. But implementation difficulty is on us. That's great. Just benefits. Bit experimental, not on every tile provider yet. That's gonna coming in next year. So, why are we doing vector maps anyhow? And how are we doing vector maps a bit? Vector maps work by tiling the planet in the quad tree, and not giving a fuck about distortions, not giving a fuck about all these other things, and then just shipping the data to the client. And we are going to render the data depending on a style which you give us, which can be runtime dynamic, i.e., for example, I'm driving into a tunnel. Okay, now the map gets dark, which is nice. And you want it to be this kind of dynamic, or if I long tap on the main city of India, then the main city of India gets larger from an icon perspective, or some small image gets popped up. It's also interactive. So these sort of things require vector maps. They are not possible on the previous kind. Yeah. Our tiles, our style can be edited by. Oh, that slide was thrown out of context, I think. That slide should have been much earlier in the presentation. We have a style editor which you can edit our styles with. If you want to make them sort of more dynamic, you can also do that at runtime. Yeah. Also, no, these slides should have been much earlier in the presentation. Sorry about that. Yeah. Yeah, our tile server is, according to a few benchmarks, the most performant out there. Those benchmarks are slightly rigged towards us, though, so do your own benchmarking on that one, on your own data. So yeah, we are quite fast, so that our histograms up there are look quite broken, because like you can't benchmark 0. Yeah, that's fun. We also try to be reasonably nice to work with on like many fronts. Yeah. But like, what have we been up to in the last few years? Because like what I've already showed you, like that's old news. So what have we done? We have worked on a tile specification. It's like we noticed this MBT stuff has worked out in 2012, and we in 2012 we designed it for being simple to use and simple to build. And yeah, well, being simple is not the most performant, so we are now doing a much more complicated format, which wouldn't have been possible in 2012 due to engineering constraints, and now it's possible, and it's much faster, 3 times faster on regular data, up to 6 times faster if your tiles are ginormous. It's round trippable, allows pre-tessellation, allows you to do SIMD stuff with it, maybe even able to be directly copyable to the GPU, which is then gonna be even faster. So there are a number of performance benefits going on. We're also currently in the process of migrating our web renderer from a WebGL to LimanGL, which allows us to have web GPU support for extra performance, more future. It's a future-proofing strategy, basically, where you then can write your shaders in LumaGL, which is much more comfortable than writing the WebGL shader code, which you previously had to write, which like actually not very approachable for regular humans or regular developers. So yeah. We also last year released our globe projection, so now we support the web Mercator projection and the globe projection. I think that with these two, we kind of support both of the projections that you might want. You might differ on that. We can talk afterwards. So yeah, things are great. We also released the refactorings of the Vulkan and Metal API transitions, which allows us to be much more performant on both Apple devices and Android devices and embedded devices for a number of reasons. Yeah, and we now also have PMTile support on the phone, which means that I now don't need a server anymore to run my iPhone app, which is great. So, thanks for listening to the first part of the talk. And you can stay up to date or join our community at either of these links.
Thank you, Frank, for this update on the MapLibre project. So now we are open to questions for this first part, and we have second part after this, starting in just, so I think we have 15 minutes left for the next talk.
Sorry, I was a bit fast apparently.
What do you mean by 6x? Can you define that x? You have defined your 6s faster.
Our success is, our success is primarily due to having a large community behind us. Or what?
What is that x? 6x you are telling 6s faster.
6x. Well, if your tiles are unrealistically large, then you get 6x performance increase. But realistically, your tiles are not going to be 6x large. You're not going to, like, if you are going to benchmark it, you're going to get 3x improvements. Because your tiles in India are not going to be stuffed to the brim with so much shit, like figurative shit, that you're gonna get the 6x performance improvements. Those 6x performance improvements are happening in Germany in very specific environments if you are actually including all the data. So unlikely to happen in...
So if I use Indian data, I will not get 6s.
You will get 3x. 3x is the marketing figure which we think is reasonable. 3x the performance in the decoding and 3x smaller tiles. It's like roughly the goal which we think is a reasonable measure. 6x is if you're if you actually have like if you're still running open map tiles schema and running it on Germany, because Germany has wildly more data.
Basically, you are doing a rendering vector-based rendering. Am I correct? You are not using a raster-based rendering.
What?
Your rendering is on vector data.
Yes.
Okay. Then why this difference has to come? You are not rendering raster data.
Yeah.
You are rendering vector data.
Yes,
so
and?
Why it's such a drastic difference?
Such a drastic increase. Well, I've had a talk on this yesterday, but the basics is that we now previously the MBTs, where is it? Let's go to the correct slide deck. Sorry. So that's an MVT. MVTs are based on doing string interning as the only optimization. They basically are using plain encoding for most of the things. If you're sending a float over the wire, you're gonna get a floating point number. There's no compression, no lightweight compression applied. That's why you currently need to gzip your tiles. Our next generation tiles does not need to be gzipped because, well, if our tiles were to be gzippable, it would not be a good format. Because gzipping is like these heavy rate compression algorithms are reasonably slow, and like we don't want to be slow here. That's a critical path to you dragging the map and the new map tile plopping up. So every millisecond matters here. So every performance improvement we can get out of here by not having this, not only having this reasonably stupid dictionary encoding, but also having a bit more complicated encoding scheme. So basically, previously you had these, okay, I'm sorry about the camera. Previously you had the dictionary encoding and plain. Nothing else, but these two. And now we have all things, which the rest have performance characteristics which are nice for some use cases, but you don't want to have them for all use cases. So it is more complicated, that's why it was not written this way, but it's also more performant.
Since you have app already developed, will you be able to show one small live demo? A live usage of your...
Sorry, could you speak up a bit? I'm a bit hard of hearing.
Am I audible? Yeah, since your product is already in market, can you show one small live demo?
A live demo, I think so, but I would need to search it up. It's on our website, on the demo tiles website. So yeah, but it's not very impressive because, well, yeah. Or at least I don't think it's very impressive because it's just a map. It renders faster. And that's very nice for the use case where you're struggling with performance.
Great. Thank you for the question. Anyone else?
Hi, Frank. Many times I required the 3D rendering of terrain and even the crystal models and geological maps in 3D. So, what kind of performance I can get if I use in place of CZM and other libraries? Because WebGL is known for rendering the things in 3D.
Yeah, we support 3D terrain. We don't support the things that Cesium does. And that's a little bit by choice, because like there is competition out there which is running for Cesium.
So that is what I want to know, is how fast, or if you do the comparison, means
Well, on
performance-wise, if you
3D terrain, I honestly don't know how fast we are compared to Cesium. I know that the map, if you drag it around in Cesium, feels super laggy, and our map like doesn't feel laggy. So at least anecdotally, that's better. But like I don't have I haven't done the actual benchmarking on this, so I don't know. Would need to do the research on that one.
Okay.
But like, if it feels like, if you drag the map around and feels faster than Cesium, it's likely faster. But I just don't know how much the quantifier is. But we don't support the 3D tiles. that's not currently in scope.
Okay, thank you.
That's what you can go to the people outside from Earth.
Thank you. Any other question? All right. So I think we can now start with the next talk if you're ready.
Yeah, I'm ready.